We've always heard that school is cool, but today we're going to be learning about what makes it hot. Now, we're going to be learning about the 4 modes of heat transfer. Before we get started, I want to tell you about one of the laws of thermodynamics. Now, don't worry, it's a long word, but it's pretty simple once you break it down. The first part of the word is thermo, and this simply means heat. The second part of the word is dynamics. This word, or this root, means change. Thermodynamics helps us study the relationship between heat and energy. For example, heat produced when coal is being burned may be used as energy to produce electricity. There's more than one law that you're going to be learning about in the future, but as for today, we are just going to be talking about the second law. Now remember, as we're talking about this, I want you to keep up, start filling things in on the worksheet I've given you, that way you can study this later. Now the second law states that the transfer of energy flows from the higher temperature to the lower temperature. So, imagine this morning, Miss England gets up, she has a rough start and decides to make herself a nice hot cup of coffee. She finds out that's a little too hot for her liking, so she decides to put an ice cube in it to speed up the cooling process. Now, the coffee is at a lower temperature, but in what direction is the energy flowing? On our worksheet, I have a picture of my coffee and the ice cubes that I put into it. I need you guys to draw an arrow indicating the flow of heat here. Now, is the heat flowing from the coffee to the ice, or from the ice to the coffee? Who thinks that it's flowing from the ice to the coffee? Show of hands. Alright, now how about from the coffee to the ice? Awesome, it flows from the coffee to the ice because coffee is at the higher temperature and it's transferring heat to the ice, which is at the lower temperature. Now, there are 4 main ways that heat can be transferred, and here's an easy way to remember each one. Always remember that Cesar Chavez Academy rocks. Now, each first letter in this sentence is going to help you remember one of the 4 ways that heat can be transferred. Now, we have conduction, convection, advection, and radiation. Let's start off with conduction, Cesar. It can also be referred to as diffusion. So if you don't want to make the mistake of pairing it with convection instead of conduction, just remember that conduction has a D in it, just like diffusion. Conduction is a type of heat transfer that occurs when 2 objects are in direct or indirect contact with one another. So here's an example. In my coffee cup, I have hot coffee. This is my heat source. An indirect interaction is when it is flowing through the coffee cup to my hand. If I simply stick my hand in, that's an example of direct contact. Now, I want everyone, take a hand, left or right, doesn't matter, and I want you to touch your forehead right now. Now, chances are that your hand probably feels cooler to you. In this case, heat is flowing from your forehead to your hand. So, we've got conduction going on right in front of our faces, literally. Next comes convection. When heat is being transferred by convection, it's being moved vertically through a gas or a liquid. As I'm sure you'll remember, if something's moving vertically, it's moving straight up and down. Now, if you see a pot of water boiling on the stovetop, what do you see leaving the pot? You see steam. Now that's the movement of heat escaping as a gas when the water vaporizes. Let's move on to advection. Now advection, which is academy in our mnemonic, is really similar to convection, except that the heat is being transferred horizontally, so from side to side, because vertical is up and down. Now, let's go back to our pot of water boiling on the stove right now. If you look into the pot of water, what do you see? It's not completely still, is it? You see bubbling and churning of the water. If I put something in the water, once it's heated up, we have a way of seeing the transferring energy because it's not going to come up in the steam. It's going to continue moving in that body of water. In nature, this is one way that pollution can spread through a pond. Since the pond is still, once the pond has thermal energy introduced to it from the sun, the pollution is able to move the pollution all over. Finally, we have radiation. In this mode of heat transfer, energy is transferred through electromagnetic waves. And here's electromagnetic. just for future reference. Now these electromagnetic waves are how energy is transferred from the sun to the earth rather. And since there's no water or air in space, energy has to travel through these electromagnetic waves. Because if the sun ever directly touched the earth, we'd all be in trouble. But it's still able to make a summer day warmer, melt your snowman. So I'm going to try and bring this all back together with a few examples. Now Rachel has kindly volunteered to help us out with some demonstrations to help us get a firmer understanding of these ideas. Now, say I want to give this ball to Rachel in 4 different ways. This ball represents heat, and I represent the heat source. Rachel is going to represent the final destination where the heat is being transferred. So, the first way that I might give it to her is by directly handing it to her, as so. And because we came into direct contact, this is called convection. And remember, we can also call this method diffusion. Next, I might release the ball and have it hit upwards in the air until she catches it. Since it's moving vertically up and down, this is known as convection. Now, does anyone remember the difference between convection and advection? In the case of advection, the energy is traveling horizontally. So in this case, I might place the ball on the ground and kick it around, have it bouncing off the walls until it arrives at Rachel. Now, finally, we have the mode of radiation. In this case, I'm not going to come into contact with Rachel at all, because if you'll remember, energy is traveling through electromagnetic waves. Now, thank you, Rachel. So now that we have a better idea of what each mode of heat transfer is all about, let's look at the last item on our worksheet. Here we see each of our 4 modes of the transfer listed with 8 different questions. We're going to use each of these terms twice and match them to either a definition or an example. I'm going to give you a few minutes and then we'll go over these together. Alright, let's go over these answers, guys. I feel like everyone's had a chance to at least take a look at each one of these. Alright, our first question says, you accidentally touch a hot stovetop and it hurts your hand. Now, think of this. We're coming into direct contact with a stovetop. So what is this an example of?
Conduction.
Conduction. Awesome. Now, number 2. Heat is transferred through electromagnetic waves. So in this case, we're not coming into direct contact with it, and we're not using gas or fluid to transfer energy. So that leaves us with one option. What is that?
Radiation.
Radiation. Awesome job. Now, number 3. Steam is rising up from a boiling pot of water. Now think of the phrase I just used. Rising up. So in this case, we know that it's moving vertically, straight up and down. That would mean that the answer is what?
Convection.
Convection. Exactly. Number 4. Thermal energy results in altered ocean currents. Now this one's a little tough. I have given you a hint that you need to think horizontal, but think of it this way. Thermal energy in the tropics often can cause inclement weather during hurricane season because it's altering currents, and these currents are moving horizontally. So that means this is which mode of transfer?
Advection.
Advection, that's exactly right. Now, we have number 5. Heat is transferred when 2 substances are in indirect or direct contact. Now, what is that example of?
Conduction.
Conduction, exactly. On to the next. We have number 6, which says that the sun heats up the earth and melts snow. Sun is not coming down to touch the earth, and that means that it's traveling through electromagnetic waves, making this mode of transfer
radiation.
Radiation, exactly. Now, we have 2 left, and if you've been marking off your answers as you've been going, you know that we have convection and advection left. And these last 2 definitions are virtually the same, except one word has changed. Heat is transferred through a gas or liquid either vertically or horizontally. Can someone tell me in which case it's transferred vertically?
Convection.
Convection, exactly. Now, in which case is it moved horizontally?
Advection.
Advection, exactly. Awesome work, team. Now, I have one last thing before I let you go. Is anyone here a Jason Derulo fan?
I am.
I am too. Awesome. Then you might like this heat transfer transfer song. We're going to listen to it here, and here's a little treat for you. If you can perform this either individually or in a group before our next test on Friday, you will receive a whole 10 extra points on your test. So let's take a look at the video. Alright guys, do we have any questions, comments, or concerns? If not, I will see you all tomorrow. Grab a review worksheet on your way out and have an awesome day. Throughout the day as you're going through school and even when you go home, be on the lookout for examples of how one of the 4 modes of transfer is being demonstrated in real life, and tell me about it tomorrow. Have a great day.